My name is Dr. Shanti Farida Saleh. I'm from the Center of Excellence for Renewable Energy. This is a Center of Excellence under University Malaysia Sarawak. So today I'll be talking about the biomass potential in Sarawak. This is from our perspectives and the ongoing activities that we have. Before I go further, I would like to briefly talk about what would be covered in my presentation today. I'll be talking about the very brief overview of Sarawak biomass. Actually, I have prepared quite a detailed data, but due to some unforeseen circumstances, some data cannot be presented today. Nevertheless, I will highlight the ongoing activities of our center, which is related to the biomass activities. Right. As we all know, agriculture is one of the major economic activities in Sarawak, in spite of the oil and gas activities. And what is unique about Sarawak is that apart from the common commodities such as palm oil, paddy, coconut, we have our own indigenous plant or resources that we can tap in, which can be a very good potential as biomass production. If we compare to Sabah and Peninsular Malaysia, we are still very young at the palm oil plantation because we just have started. And it is been estimated in maybe in another 5 years, we will start to reach our full capacity of our palm oil plantation, so that we could have a very good resources of our palm oil meal palm oil meal residual or waste. Right. When we talk about Sarawak, I suppose that some of you have already known that Sarawak covers a vast area, okay, and therefore the plantation and the mill itself is scattered all over the place. So one of the challenges that we have to face is in terms of the logistics of the waste or the biomass itself, and how we are going about to centralize it or to integrate it if we were to have a big scale biomass conversion or biomass biorefinery. That's what we try to call it from now on. Right, here are the challenge and the focus that we, Sarawak, are taking into consideration, realizing the limitations that we have. Because some people said that, if you cannot beat them, you join them. But for us, we see it from a different perspective. We are trying to actually focus into a more high-value products, like bioengineering products, value-added chemicals, that require less feedstock, but can give us higher returns. And another thing that we would like to keep in our mind so that we could sustain whatever activities related to biomass is that these activities is actually something that we do to save our environment, and it is a part of our corporate social responsibility, rather than we focus too much on the investment return. This is something the industry might not so interested to know, but this is a thing that we have to also keep in mind. Right. I suppose if any one of you are very familiar with biomass, this is a very comprehensive structure of how do we make a best use of biomass, right? So basically, we are very familiar with the term of gasification, the pyrolysis, the burning, bioethanol, so on and so forth. But we would like to take this approach into our ongoing research and consultancy activities, so that we could actually diverse our activities, so that whatever that is related to biomass is something that is sustainable. And we are not saying that we have completed all of this. We are trying to map whatever activities that we have back to our resources, because some of the resources that we have is very unique to Sarawak that is not available in other parts of the world. So back to the major resources in Malaysia, which is the oil palm. We do have our oil palm plantation. And this data is obtained from the Sarawak Energy, who is responsible for our energy study in Sarawak. And overall, if we take into account every part of the biomass resources that we have, from these two major resources, we have about 425 megawatts of potential electricity, talking about 32% of efficiency. Now, if you ask, do we have this in Sarawak? At the moment, we don't. This is because of the challenges that I have mentioned before, okay, regarding the logistics, the grids, because if you would like the end users to enjoy the electricity, you must have a proper grid, which the geography limitation in Sarawak has caused us a bit of problem and delay in fully utilizing this potential. Anyway, nevertheless, okay, we have tried to focus on something that does, that does not require for us to invest a lot of money on having the plantation, the power itself, or talking about the grid. So these are the other biomass that is also has a very good potential when you talk about Sarawak itself. If you look at sago, yeah, we have three components. The sago itself, which has a very high potential in the biofuel, as well as high value-added chemicals. When we talk about high value-added chemicals, we talk about chemicals that has a very high value, for example, xylitol, which is very, very expensive and high demand in pharmaceutical industry. Talking about the sago waste is a very interesting characters and properties. It is because of the ability to absorb water and retain water. It is a very good biosorbent and also very good polymer to replace the conventional food packaging that we have at the moment. And also we have done some work on the possibility or the potential to use it as a fire-resistant materials. Paper waste, as you know, Malaysia is also one of the producer for paper, which has a very good potential for biochar, and as well as the biopolymer. And also in Sarawak, we are looking at the potential of the landfill as one of the resources of energy. When we talk about a 38% of energy efficiency, the total power potential in Sarawak is about 2.3 megawatt. We have our counterpart in Sarawak, the one who manage our waste, which is under Trinican's company. They have claimed that they can get about 10 megawatt out of their existing landfill at the moment. Sewage, we are trying to look at the sewage, but so far it is not very attractive due to content of water that is very high in our sewage. Sago wastewater, as I mentioned, we have currently about 200,000 cubic meter per year, which can generate about 11.1 gigajoule of energy. Cocoa is also one of our biomass, and the cocoa husk, because when you talk about cocoa plantation, basically only 10% of the cocoa is being used for the chocolate or whatever production, while the 90% remaining is considered as waste, which is a lot. So basically, part of the works that we have done on this is on the gasification of the cocoa husk, which can contribute to about 240 gigajoule of energy in total. Right. Coming to talking about the uniqueness of Sarawak state, we have a Sarawak Biodiversity Center, which is a center that holds a collection of natural products systematically that is collected from the Sarawak rainforest. When you talk about biotechnology, right, this is where this biodiversity comes into playing a very important role. And so far, they have about more than 20,000 extracts of plants, as well as 14,000 of microbes. And they are working very closely with one of the Japanese leading company in terms of the biotechnology part of biomass conversion. Okay, introducing our Center of Excellence of Renewable Energy. Actually, we have started back in year 2009. And biomass is not just one of the area that we are focusing in. We have all sorts of renewable energy, as you can see on the slide. And these are just a few ongoing projects that we have in our center. We have about more than 20 projects completed, and also about 10 new projects coming in into our center. Right, today I would like to share, I would like to highlight a few things about important potential of biomass in Sarawak, because I don't want to replicate what others have been doing. Some have been talking about the palm oil mill, some has been talking about the palm oil mill effluent. So today I think I would like to highlight the uniqueness that we have in Sarawak. As you know, the Sarawak has quite plenty of peat soils, which we consider as a very high quality of soil that is considered as unwanted soil, right? It's covering about 1.5 million hectares, and most of developers are trying to get rid of this soil. So we have done study on this, and we found out that the calorific value of this is between 10 to 20 megajoule per kilogram. And this research or activities has been started due to the intention of helping the people in rural area of Sarawak, where the limited resources of the gas and diesels that they are facing. So then we found out that there are a lot of good things about the peat soil that we can further utilize as one of the source of energy. Right, we call it from peat to heat. So basically what we have done is that we have a collection of our peat soil, and we enhance the property by adding some additive to enhance the combustion and the burning of the peat soil itself. And then to make sure that it is very easy to use, we pelletize it, and so that it can be used as alternative fuel for cooking. And this is just to show you the data of the effect of different additive and the ratio that we have done to the additive and the peat soil, and the results that we get. And we have found a very interesting results on the use of the peat and the cooking oil. This is the used cooking oil, which has the highest calorific value out of all the additive that we have tried. And we know that we are trying to get rid of the used cooking oil, and this is one of the method that we can use to also save the environmental problems that we are facing. This is nothing new, actually, because European countries like Sweden, Russia, and Ireland, they have been using this actually up to the commercial usage to power up the thermal power plant. So we haven't done this in Sarawak yet, because we have just started, and we are now looking at the scaling up of this peat to be used at industrial scale. Right, back to the rural area application. In order for us to help people in rural area, we are trying to design what we call a My Peat Cook, which is a very special cooker using the peat as to replace the coal. And we find out that this cooker actually, it does work, and it's very portable. And it's very easy to operate, which is very helpful for the rural people. Okay, this is the one of the prototype that we have, and at the moment we are also keep improving the design to make sure that we have to maximize the efficiency of the peat as the fuel source of this cooker. Right. Another thing that I would like to highlight is actually the concept of cradle to cradle. Right. This is actually one of the effort to scale up what we call a low-cost biosorbents for removal of dissolved peat swamp runoff. This is using a coconut copra. Okay, the coconut copra. We are doing this at a very sustainable environment, meaning to say that at a room temperature, at atmospheric pressure, no chemicals added, and we are trying to use this coconut copra to absorb the humic substances from the water and treat it for drinking purpose. And the results that we get is very encouraging because the water quality that we get is as good as the drinking water quality. And plus, the humic substances that has been absorbed by the coconut copra actually is a very good source of fertilizer. We have run this together with Departmental of Science Resources, and they have tried the tomato plantation using the coconut copra that have absorbed the humic substances. And it has been proven that the tomato plantation that I have grows very well using this coconut copra. So it's basically a cradle-to-cradle approach that we are using. So nothing is being wasted. So we return back the carbon to the soil. And the last thing that I would like to share with you today is on the other ongoing activities related to biomass that we have in our center. Biofuel, we are also working on bioethanol and biodiesel as of any other resources. Now we are at the pilot scale. Actually, we have done pilot scale project on the biomass to heat converter. You can come to our booth to look at the poster because we cannot bring the model here. It's too heavy and it's too big for us to bring to Kuala Lumpur. And we also have been producing some of the bio oil. As well as the biofiltrations, means that we utilize the agricultural waste as part of our filtration medium. And also we are working on the converting what we call a negative value agricultural waste, which people don't want and has no value, into activated carbon, into biochar, into special polymer, means that polymer that can replace the existing polymers, which is not biodegradable. So we are trying to make it biodegradable. And also now we are also working closely with some of semiconductor industry in phytoremediation, means that we use plants to treat their heavy metal in the wastewater. All right, with that, I would like to say thank you. And I would like to conclude my presentation today. And I hope that this sharing does benefit every one of you here. Thank you.